Good morning, students.
Good morning, sir.
Very good morning. Right. So only 30. Still the students are coming. Anyhow, the last class, yesterday we discussed about the alkanes preparation and as well as the cycloalkanes preparation. In the examination point of view, the two preparations are very important for essay type question. The general method of preparation of alkanes. That is mainly first method is hydrogenation, second is Woods reaction, third is Grignard reaction, fourth is Kolb's reaction. And in this only the chemical property, the halogenation of alkanes. Halogenation of alkanes is a chain reaction. It is a free radical mechanism involved, so that you have to use that particular mechanism in that chemical property. That is the one important one. Sometimes it is asking for the separate question as a 5-mark bit. So alkanes also, you know, that is a saturated hydrocarbons. The general formula is CnHn plus 2 is also called as a paraffins because of little affinity is there. Due to that reason, it is present, and the natural sources are petroleum and your natural gas, which is present with the sources of the alkanes. And alkanes is also homologous series is present. That is adding of that one, but you are getting off the natural gases. Okay, the homologous means it is a consisting of the difference between the one carbon atom, two hydrogen atom is called as homologous. So this particular alkanes, we are adding our 4 preparations and one general method is present. That is enough. Why? Because these are very little affinity is there. Under normal condition, they do not undergo any chemical reaction. Only under drastic condition only that particular alkanes can undergo the particular chemical reaction with the sunlight. The chlorination will take place, and also by the combustion of the alkane means combustion means it will oxidize, nothing but we are burning. When the gases are burning means you are getting the carbon dioxide and water, and some energy will be released. When the bike is running means due to of the petrol is running. That means you are ignited. Due to of the ignition, carbon dioxide, water is above. That means emit out, and energy. That energy will be running of the vehicle, either motorcycle or petrol, or car or bus, whatever it may be. This is a combustion will takes place. Okay, nitration also takes place under drastic condition. That means it is required, the heat is required. When the alkanes under nitration, that is a nitration mixture is sulfuric acid and nitric acid, formation of nitroalkanes are formed. The nitroalkanes, but the condition is you are required some amount of that heat, temperature is required. So yeah, the temperature may be 60 degrees or sometimes 100 degrees. So sometimes you are getting of the more nitro groups means you are getting of the 180 degrees also. That is depending on the conditions you are getting of. Next, cyclopropanes. The cyclopropanes, already I told that the first and the member of the family is cyclopropane, cyclobutane, and so on and so forth. We are getting this in this particular cycloalkanes preparation will be the main important preparations are Freund method and Perkins method. From the Freund method, you can prepare any one of the cycloalkanes, cyclopropane, butane, and pentane, hexane, whatever you want, you have to prepare from means of the Freund method. But the Perkins method, we can only prepare the cyclopropane only. Why? Because we are using of the ethylene dibromide and disodium malonic ester is used in the presence of ethyl alcohol is the catalyst, so that you are getting of the only cyclopropane. One more, the last is the reduction. Is the reduction means only when adding of the hydrogen, in particularly benzene is reduced in presence of, that is particularly red hot tube, it is called as it will be formation in the hot, the very high temperature is required, so you are getting of the cyclohexane is formed. There is a, okay, that is about the cycloalkanes preparation. In that, I given as a small exercise. One means the properties. So only cyclopropane, the 3-membered, 4-membered alkanes, cycloalkanes, can undergoing the addition reaction. That means with the hydrogen or with the halogens or with the hydrogen halides. Only cyclopropane, cyclobutane is undergoing that one. But remaining cyclopentane, cyclohexanes are not undergoing with the addition reactions with the hydrogen or chlorine or hydrogen halides. Why it is means they explain, it is explained by the Bayer-Strain theory. Only cyclopentane and higher cyclopentanes are undergoing substitution reaction, not addition reaction. Please remember saturated alkanes. That means saturated alkanes can undergo only addition reaction or substitution reaction. They will ask the question. The saturated reaction, we are getting off hydrogenated, means addition reaction is hydrogenated. It is added. Do you add the saturated compound? It is already saturated. You can't do the addition reaction. Only saturated hydrocarbons can undergo substitution reactions only. That means nitromethane. It is a substituted nitro group. Halogenation, substituted halogen group only. So remember, this point is saturated hydrocarbons can undergo only substitution reaction. They do not undergo addition reaction. Please remember. So saturated cycloalkanes also do not undergo addition reaction, but particularly cyclopropane and cyclobutane is undergoing addition reaction. There is a cause. Due to that reason, Bayer-Strain theory is explained as what he feel as Bayer is all cycloalkanes are planar in structure. They are in planar. Due to the planar means they are having of the normal bond angle is 109 degrees 28 minutes. Actually, they want the 109 degrees 28 minutes, but really you are thinking of the cyclopropane is having of 60 degrees, cyclobutane is a 90 degrees, cyclohexane, pentane is a 108 degrees, cyclohexane is 120, cycloheptane is 129 degrees. Due to that reason, some bond angle strain may be present. He believed that. So that he calculated angle strain. How much of angle strain is there? Due to the angle strain, cyclopropane and cyclobutane. Cyclopropane is having of the 24 degrees, more than the 24 degrees of the angle strain is present, and cyclobutane is more than the 9 degrees angle strain is there. Due to the angle strain, to relax, to release the angle strain, getting off that one, they are undergoing addition reaction. Why they are undergoing addition means because of the release the angle strain to free getting of the loose chain, that means straight chain, so that the particular cyclopropane and cyclobutane is undergoing addition reaction. But in the case of cyclopentane, it is undergoing only substitution reaction. Why? Because there is no angle strain is there. Zero angle straining, almost all negligible angle strain is there. I am using of negligible, don't have the zero. Negligible angle strain is there. Due to that, it is undergoing only substitution reaction, not addition reaction. But the case of cyclohexane and heptane, those two are also undergoing substitution reaction, but they are having an angle strain. Angle strain is there, but they now do not undergoing addition reaction. Why? If you ask the Bayer, we don't know. The answer is we don't know. So that immediately, whatever the defect is present in the Bayer-Strain, the Saxe-Maurer theory is established. That is called as Saxe-Maurer theory is formed. What is Saxe-Maurer theory? He explained that all cycloalkanes are not in planar structure. If it is a planar structure means the bond angle is 109 degrees 28 minutes. There is no bang and the angle strain is there. So he says that, Saxe-Maurer says that only cyclopropane, cyclobutane is a planar in nature. Those are all planar in nature. Remaining are not in planar. Planar means they are having of the blank angle strain is there. So due to that reason, cyclopropane and cyclobutane is undergoing addition reaction, but more than 5 or 5 more than the 6 carbon atoms. That means more than 5 carbon atoms, whatever the cycloalkanes are there, means cyclopentane, cyclohexane, cycloheptane, and higher, and so on and so forth. Those are all not in planar structures. He believed that Saxe-Maurer. So that he says that cyclohexane is having of 2 conformers. They are having of the 2 conformers, that is called as a chain conformation and also boat conformation. chain conformation and both two conformers are present. In the chain conformation is more stable because of at room temperature, cyclohexane can exist as a chair conformation only, not boat conformation. Why this particular means the whatever the angle strain is present, some 5 degrees are present according to the Bayer strain theory. Due to the boat conformation is having of the angle strain, but not chair form. He says, he is proved that one. So according to that one, whatever the so what your point of view, here the angle strain is present because of the, I'm using of that one, Saxe-Maurer theory. Saxe-Maurer theory. So what he believed, all cycloalkanes are not in planar. Only cyclopropane and cyclobutane is only planar. Remaining higher members means hexane, that is a pentane, hexane, heptane, like that. Those are not in a planar structure, but they are having of the conformers. Conformer means they are having of two more structures. More than two structures, sometimes more than one, you can say. Sir, he explained with the cyclohexane. This cyclohexane is having of two conformers. These are having of two conformations. That is, one is called as chair form. Another is called as a boat form. Why it is called as a chair form, boat form, sir? Let us see the first one. I'm using of that one. Chair form. See, in the examination, you can draw by like this only. By seeing of the picture, you can't draw perfectly. So by this, you can easily draw this picture. See, this is a chair form. Okay, you are sitting on this one. This is a chair form. In this particular having of the electron, that means hydrogens are placed like this. This is the hydrogens which are keeping off. Okay, friends. If you observe my drawing, what is the nature I'm using of this one? Please use these techniques while drawing in the examination. This is called as a chair form of the chair conformation. And you know that boat form, easily write boat form. That is a boat-like structure. This is a boat-like structure. Okay. Here. These are the hydrogens which are present in the boat form. Okay, friends. This is about the boat form. I'm very close. This one. It is not like that. This is a form. Okay. So this is about the boat form. Now see the number of carbons. That is the first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. Here also this is the first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. Right, friends? These are the two conformers are present in the cyclohexane. What he explained, why they do not undergoing addition reaction, he explained as they form the two conformers. In the two conformers, chair conformation only present at room temperature. At higher temperature, both are present. Due to the higher temperature, this boat form is having of the strain according to the Bayes. Whatever the strain is showing, that is derived by the Bayes. This particular boat form is showing of strain. How it is strain? Let us discuss about what is the strain is present. See this one here, boat form. I'm explaining the boat form. First carbon, second, third, fourth, fifth, sixth. In this carbon, 6 carbons, second and third, sixth and fifth carbons are on the same plane. On the same plane means you are present. You are having a third and also fourth. That is second, third, sixth, fifth. These are the C2, C3, C5 and C6 on same plane. They are having, and C1, C4 above the plane. This is the above. This is the plane. Above the plane, this is a C1 and C4 are there above the plane. Okay, friends, here this above plane is having of carbon 1, this carbon 4. This particular hydrogen is called as, I'm using of this particular hydrogen. Okay, so let us say I will use the different color. So friends, I'm using of red color, this particular. Maybe not, may not be visible. I think so. Okay. This is a red color hydrogen that is close each other, and one more hydrogen is there. This is on the fourth carbon and as well as the fifth carbon. I'm using the green color. See this one green color I am used little bit for your clarification only. I'm using this one. Okay, different colors. See this hydrogen, whatever the nearer, very close hydrogen. These hydrogens are called as flagpole hydrogens. These hydrogens are called as flagpole hydrogens in the boat form. This hydrogen, that means green form of hydrogen, is called as bowsprit hydrogen. This hydrogen is called as bowsprit hydrogen. That is named by the Saxe-Maury. I don't know why it is famous. Flagpole hydrogen and bowsprit, two hydrogens are present on the C1 and C4. Those are on the above the plane. And here flagpole hydrogens are very close each other. Due to the flagpole hydrogen, there is a repulsion is there. Here the repulsion because of very nearer is there. But bowsprit hydrogens very far, there is no repulsion is there. Due to of this repulsion, whatever the flagpole hydrogen, the boat form is unstable. That strain, whatever the strain is calculated by the Bayer, due to of this hydrogens only. That's why the boat form is not stable than the chain form. Coming to the, I hope you understand that one. Means C2, C3, C5, C6 same. The carbon atoms are, that means on the hydrogens are same plane. Only two carbon atom hydrogens are above the plane. In that C1 carbon, one hydrogen and C4 hydrogen very close each other. These are called as a flagpole hydrogen. These flagpole hydrogens are, there is a repulsion is there because of very close each other. Due to of the repulsion, angle strain is possibility is there. Angle strain is present. But the bowsprit hydrogens are very far. There is no repulsion is there. In this case of boat form. Coming to the, you are having of the chair form. Here chair form is first carbon, second, right, that I have already used. Here on the same plane, 2, 3 and 5, 6. C2, C3, C5, C6 are the same plane. Okay. And C1 is above the plane. What about the C4 is below the plane? See friends, here you are comparing with the chair form and boat form. We are comparing the chair form and boat form. These are the C2, C3, C5, C6 are the same plane. C1 is the above the plane and C4 is the below the plane. Okay, you observe. This is a, there is no meaning of, there is no repulsion is there. Very may because these hydrogens are very far. C1 hydrogen and C4 word. This is like that. The chair form. One, this is a upper leg and a lower leg. This is the upper one. This is the lower one. We are having up. So there is no meaning of the repulsion. This repulsion is there, flagpole hydrogen in the boat form, but there is no repulsion is there. Due to that, chair form is more stable than the boat form. Always asking why the chair form is more stable than the boat form in cycloalkanes. Because this is the reason only. In the chair form, C1 carbon atom is above the plane, C4 carbon atom is the below the plane. But in the board form, C1 and C4 carbon atoms are above the plane. In that one hydrogen, that is a flagpole hydrogens, are very close each other. Due to that reason, the flagpole hydrogen, there is a repulsion is there. Due to that reason, board form is unstable or less stable than the chair form. Okay, now coming to the explain one more in this chair form. This chair form, the C1 and C4, whatever it may be, when hydrogen is perpendicular to the plane, this is a plane, it is a perpendicular. See, this is a perpendicular, this is a perpendicular. I'm row, this is a, I draw, this is a perpendicular, it is a perpendicular, it is a perpendicular. These hydrogens are called as axial hydrogen, perpendicular hydrogens, called as axial. A, I'm using of HA. Okay, and this particularly another hydrogen on the same plane. These are the same plane. It is the same plane. Okay, that hydrogen, same plane hydrogens are called. Same plane hydrogen is called as equatorial hydrogen. Equatorial hydrogen. I'm using of this is hydrogen is E. This hydrogen is A. See friends, every carbon atom having of two hydrogens. One is the axial hydrogen, another is the equatorial hydrogen. There is no repulsion between the axial and equatorial hydrogen. Axial means it is a perpendicular to this particular structure, that is called as an axial hydrogen. This particular hydrogen is plane to the same. The same plane is present, that is called as the equatorial. So this is the equatorial here. This is axial, equatorial, this is axial, equatorial, this is axial, equatorial, and this is axial, it is equatorial. Okay, like that we have already explained the Sachs-Moore theory. This is a theory which is present. Why? Because he explained whatever the defects is present in the Bayer-Strain theory. Why? Because according to the Bayer's, cyclohexane is also having up some strain is there. Why strain? Because of this board form is having up strain, not the chair form. Chair form is a more stable. It is having up, this is the structure. Okay, this much you have to explain in the examination point of view. This by the cycloalkanes is brief. Okay, next we will go to the next topic, that is a unit 3, that is alkenes. So friends, we'll discuss about the alkenes and alkadines. First of all, I will discuss about the alkenes only. I'm discussing about the alkenes first. Let's hear. What is the alkenes? Alkenes is nothing but there is a double bond between the carbon and carbon. There is a double bond is there. Why? I became written as a double bond, remaining two bonds, because the carbon atom is having a tetravalency. 1, 2, 3, 4. This is consisting of double bond. That means when a carbon atom between the carbon and a bond is present, that bond must be a sigma bond. Next bond is present, that bond is belongs to the pi bond only. First, you are combining. Combining means it is a taking place of the head-on-head overlapping or axial overlapping. Due to the axial overlapping, a sigma bond is present. A compound is formed means only because of the sigma bond. Then if the number of bonds are increases, that bond is belongs to the pi bond. So alkenes is having of one sigma bond, one pi bond is present compulsory. Okay, this is about the alkenes. Next, this alkenes general formula is CnH2n. This is a general formula of alkenes is CnH2n, and this particularly alkenes. If you see the members of the alkenes, first you have to remember the alkenes are compulsory 2 carbon atoms are there. Alkenes only 1 carbon is there, methane is there, but here 1 carbon family is not there in the alkenes because you require the double bond is there. So C2H4, it is called as ethene, but actually this is used commonly. I am pronouncing this is ethylene. IUPAC name is ethene. And C3H6 propene. And C4H8, it is called as butene. See friends, we are using of this one. This is the formulas. If you see C2 ethylene, ethene, propene, butene. Now ethene, propene, what is the difference is there? 1 carbon atom, 2 hydrogen atom, and propene and butene difference is 1 carbon atom, 2 hydrogen atom. These series also called as what? Homologous series. So nothing but alkanes are the homologous series. Alkenes also homologous series. Okay. So friends, this is a homologous one. Now coming to the, in this family, alkenes family, the first member is ethene or ethylene. Ethene, the Dutch chemist, it is found, it is prepared from that. He observed as this is a oily natured gas. Oily, that means it is a oil nature. Sticky. It is nothing but the gas is sticky nature. The oily nature is there. So that oily nature means that is a Dutch is the word olefins. So the alkenes are called as olefins. Oli means oily. Fins. That is the oily nature of the gas. Fins means it is a gas. Oil gas. So it is also very, very important for examination point of view. Why? Because alkanes are called as a paraffins. Alkenes called as a olefins. Okay, remember this is general formula is CnH2n. So these are the important one, and in this major important is we are going to the preparations. Now the preparation is already you are using of the alkenes preparation. The first we already know to easily write hydrogenation. Yesterday I told that this is the first one. What is the hydrogenation? Unsaturated hydrocarbon means CnH2n minus 2. Okay, this is nothing but alkyne. When alkyne is hydrogenated in presence of nickel catalyst, 160 degrees Celsius is required, or 170 sometimes. Okay, so it is a 160 degrees Celsius is required. Formation of CnH2n. This is called as an alkene. Very simplest method of preparation of alkenes. Okay, this is a very simplest method of preparation of alkenes. This is the first one is a that is called as a alkenes. Second method, I'm using of the second method that is called as a dehydration of alkanes. Please remember it is a general one. Dehydration of alcohols. From the dehydration means what? Generally, sir, yesterday I was getting of the dehydration means water molecules are totally exhausted from the body. Why? Because our body is consisting of 95% water is there. That's why please remember to drink at least every day 4 to 5 liters. Our neuron cells are nothing but it is a water is present. 95% of water is there. Your body is dehydrated means the organs are does not function properly. You are getting of uneasiness, giddiness. This is your dehydration of alcohols. From the alcohols, you are removing the water molecule. What is the dehydrating agent? How to remove? So again, the question is, which is the dehydrating agent? Perfectly in the laboratory, we are using the dehydration agent is concentrated sulfuric acid. How, sir? You'll see that one example. Don't do this one in the practically. Just I'm using of the words only. Just pour a little bit of or 1 drop of concentrated sulfuric acid on your palm. Let's see. Think about. Don't do this one. What happened? The palm will burn out completely. After the seeing of that one, it is a white patch is present on that particular skin. White patch means indicate what? Water is removed your sulfuric acid so that the burning will be takes place. If you see, you are cooking in the kitchen, some oil drop, the heated oil drop is fallen on you. What do you get? The bubble is forming. If bubble is open, your water is coming out. Are you see or not? Experience. Only when the kitchen is forming up that in the kitchen hold items, then you are doing up in the cooking purpose. That is called as a dehydration. So here concentrated sulfuric acid is act as a good dehydrating agent. Here in this case, we are using of, I'm saying taking off ethyl alcohol. CH3, CH2, OS. This is the ethyl alcohol. This ethyl alcohol dehydrating in presence of what? Concentrated sulfuric acid. It requiring of temperature is immediately the temperature rises 170 degrees Celsius. Immediately water molecules is removed. Water is removed. First dehydrating agent means dehydration of alcohol means. So remaining one means here OH is eliminated. One hydrogen is eliminated. One hydrogen means here CH2, CH2. You are getting out CH2 double bond CH2. What means it is nothing but C2H4. It is nothing but ethene. So we are getting off ethene. This is the simplest method of preparation of alkenes. Dehydration of alcohols, all alcohols, any alcohol you can take, propanol or butanol or pentanol, whatever, the methanol also. So, but butanol you can't get the double bond. Why? Because only one carbon is there. Ethyl alcohol, only getting of the 2 carbon atoms are there. You are getting of the ethane. Okay, this is called as a dehydration of alcohols. This is the second method of the preparation. We'll go to the third method. Dehydrohalogenation. Third method is dehydrohalogenation. So the name is having of the meaning. Dehydrohalogen means one hydrogen, one chlorine. Halogen is replaced. One hydrogen, one halogenation is replaced. That is called as dehydrohalogenation. How the dehydrohalogenation takes place means in the presence of alcoholic potassium hydroxide. Here, the reagent, if you are remember right, otherwise simply what are the dehydrated? That means alkyl halide. Here nothing but you are taken as the initial raw material is alkyl halide. Alkyl halide. That means you are taking off. I am taking off simply CH3, CH2, CH2, Cl. Please name this one. Compound name. Compound name is, again you go to the your previous root word, primary suffix, secondary suffix, and prefix. Here root word is 3, means prop. What is there? Chloride is there. So that it is a 1-chloropropane or propyl chloride. Okay, simply called as N-propyl chloride. N-propyl. Propyl means one hydrogen is removed. So propyl chloride, or you can say your IUPAC name is 1-chloropropane. Both are correct here. You can write any one. Okay, N-propyl chloride in presence of alcoholic potassium hydroxide. That means potassium hydroxide is dissolved in the alcohol. That is called as alcoholic potassium hydroxide. It is a base. Okay, so it is nothing but the alkaline state. So this particular, immediately what happened? One chlorine atom and one hydrogen atom is replaced. One chlorine atom is replaced from this one. One hydrogen is replaced here. So for formation here, see the structure I am writing of CH. One hydrogen is replaced. So you are using of hydrogen chloride. Dehydrohalogenation. HCl is removed. So CH is removed, means it is there is a formation of double bond. What is the name of this one? Here functional group is this. So you have to remember from here only 1, 2, 3 means 1 propene. 1 propene. Ene is present at the 1 position. It is called as a 1 propene or 1 in propane. You can also write. This is called as a very, very important chemical reaction. This property, the preparation of the part 1. Dehydrohalogenation means nothing but alkyl halides, any higher alkyl halides in presence of alcoholic potassium hydroxide. You can getting of this particularly alkenes are prepared by means of this one. But here one important name reaction is there. Here Sagehoff is explained. One rule that is called as a Sagehoff rule. If dehydrohalogenation how takes place. Please friends, here why I am concentrated in this particular case. Here one chlorine remains, that is removed from the whatever the halogen present, and the rest hydrogen is removed, not here on this carbon atom. Next carbon atom hydrogen is replaced. Please remember that is the mechanism is involved in this case is chlorine. The halogen group is removed from the first carbon atom, and the hydrogen is removed from the second carbon atom, not the first carbon atom. Please remember. That's why you are getting up 1 propane. So here only the dehydrohalogenation how takes place. If suppose the compound is having of different places, that is explained by the Sagehoff rule. I will explain the what is the Sagehoff rule. Is separately asking the Sagehoff. Yeah, in the examination they are getting off separate this Sagehoff rule for 5 marks rule. That is they are asking the Sagehoff rule mark. Sagehoff. Okay. What is Sagehoff rule? Before I can explain with the example. Please tell me the name of this compound. Name of this compound. Root word 4.
2-chlorobutane.
Chlorine is present. 1, 2, 3, 4. From this means 1, 2, 3. It is not correct. Here only correct. This 2-chloro butane. Right, Amma? 2-chloro-butane. I'm using of the with what? I'm doing of with alcoholic potassium hydroxide. See, there is a chance. There is a chance is there. If alternative beta carbon is present, what he says the sage of, just listen, I can explain again. If alternative beta carbon is present, the replacing of hydrogen will be takes place. The beta carbon is having of least number of hydrogen atoms, he says. So what's that? We don't know. Let us see. Coming to my point. Halogenation. Where is the halogenation? Halogen is present on the second carbon atom. Okay. This is the first carbon, second carbon, third. I'm write this one particularly on bottom. Second, third, fourth. Why I don't want this one? Because this halogenation means halogen is present. This particularly is removed. This carbon atom is called as alpha carbon. From which place the halogen is removed, that carbon is called as alpha carbon. Next carbon is called as beta carbon. Next carbon is called as gamma carbon. If it is the next is called as delta carbon. Here no carbon is there, only delta carbon is there. Coming to the my point. This side, this is the alpha carbon, friends. You'll see this is the halogen is present. This next carbon is called as a beta, next carbon is called as a gamma. Here also there na alternative carbon atoms. Previously I taken as this is CH3, CH2, CH2, Cl. There is only this is the alpha carbon, beta carbon, gamma carbon. Immediately alcoholic potassium hydroxide. What I say, one halogen group, this group and hydrogen is replaced. So CH3, CH double bond, CH2. I written. Okay, friends. There in the commonly dehydrohalogenation, there is only one alpha, one beta is there. There is no alternative beta carbon is there. But here there is an alternative beta carbon is there. Here the beta carbon is there. This side beta carbon. This side beta carbon. Alternative beta carbon if it is available. The dehydrohalogenation is takes place. He says, Sage says that if after the beta carbon is having of least number of hydrogen atom, which beta carbon is having of least number here? This beta carbon or this beta carbon? This beta carbon means third carbon is having of 2 hydrogen. Here 1 carbon, that means that beta carbon is having of 3 hydrogens, which is the least. So this is the least one, which form the major product. Whatever the elimination of the hydrogen, which form the major product, it is written as like that. I'm using of this one. So CH3. I'm removing the hydrogen from the beta carbon of this one, third carbon, and making of the double bond and CH3. Please name the compound, please. Here I am removed the chlorine as well as the hydrogen of the least number hydrogen carbon, beta carbon only. So that one we are getting 1, 2, 3, 4 or 1, 2, 3, 4. At the second carbon we are having of this one. So 4 is there, means 2-butene. It is 2-butene. Please remember the name of the 2-butene. Right, friends? Now, there is a one alternative is there. Suppose from this hydrogen is also removed. We are getting of CH3, CH2, CH double bond, CH2. This is removed. Here hydrogen is removed. Now this one, 1, 2, 3, 4. But the one position it is there means 1-butene. See friends, this is how we are getting of 2 structures, 2 isomers. If the alternative beta carbon is present, the dehydrohalogenation takes place. We are getting of the 2 conformers, 2 isomers. In the 2 isomers, the major is 2-butane. This is a major product. It is a major product. Almost all 97% product is. It is a minor product. It is only 3% is present. But 2 alternative isomers are present. That is given by the Sage-Jaffe rule. Sage-Jaffe what it says, if alternative beta carbons are available in the molecule, the dehydrohalogenation takes place. The beta carbon which is having of least number hydrogen atoms is having of the major compound and the more number of carbon atom, beta carbon atom, that hydrogen is called as a minor product, is called as a Sage's rule. For your examination point of view, is sometimes it is asking for separately this Sage's rule. Okay, so friends, you can confuse that. That is, don't confuse here. It is getting off the 2-butene. That means alkanes are getting off. See friends, what happened? This is a 2-butene. It is a 1-butene. It is which isomer? This one. Which type of isomer? Positional isomer. The position it changes here. The second position is the first position. Positional isomer is possible by the alkenes. The double bond is shifted to the one place to the other place. That is called as the positional isomerism. Okay. So this is about the Sage's rule, which is present in the examination point of view. So these are three are the preparation. In that extra, this is the Sage's rule is present. These are preparations will over. Now coming to the properties, that properties C2 and C3. In the physical properties, that means ethylene and propene. Ethene and propene is gas state, and the remaining C4 to C14 is a liquid state, and the higher C15 from onwards, it is a solid state. This is about the physical property. And moreover, remember, all organic compounds are non-polar compounds. That means they do not dissolve in the polar solvent. Which is the polar solvent? What is the polar solvent? Water is called as a polar solvent. If anything is soluble in the water, means it is a polar solution, polar solvent. So non-polar solvents are carbon tetrachloride, ether, carbon tetrachloride. I already told that the reagent which is present in the laboratory, CCl4, carbon tetrachloride, ether, chloroform. Those are all non-polar solvents. Non-polar solvents are soluble in the organic form. Organic compounds are soluble in non-polar solvents only, but not polar solvent. Polar solvent means water. Remember, water is called as a polar solvent. Okay. So friends, next coming to our chemical properties. The first chemical property is hydrogen halides. Addition of hydrogen. Why? Because already I told that unsaturated hydrocarbons undergoing addition reactions. Only saturated hydrocarbons can undergo substitution reactions. These are unsaturated hydrocarbons. So compulsory they can undergo addition reaction only. Now addition of, you can easily say hydrogen. Already you know that hydrogenation. So what is the CnH2n? It is alkene. When alkene is hydrogenated, means you are adding, these are all are addition reactions only. I am using of addition reactions, means adding. Right? Adding in the presence of the 180 degrees Celsius. Okay. Formation of CnH2n plus 2. What do you get? Alkane is formed. That is preparation of in the alkanes we see observed. Okay. This is the first method. That means whatever the preparation methods which comes under the properties in the chemical properties. That's why you remember the major important, whatever the one general preparations are there. Those general preparations are very, very important in our exam. That means you can write one property. Suppose in the examination they won't mention particularly write the chemical properties. One of the chemical properties you can be easily to write. Otherwise, the specifically mentioned means you can write the specific name reactions only particularly. Why? Because in the alkanes, we are adding of the two specific name chemical properties are there. There is a Markovnikov rule, anti-Markovnikov rule. Let us discuss that one also. So in this case, here adding of this particularly. So first is called as hydrogenation. Hydrogenation, we are getting of the alkanes. Next, hydrogen halide. Addition of hydrogen halide. See how it is this. Simply, we are using of the simple mechanism. Suppose I am taking the same CH2 double bond CH2. I am using hydrogen halide means I am using of HBr hydrogen halide. Simply. So what is the formation? CH2. Here hydrogen is replaced here. CH3. Then removing of one bond. Why? Because broken of the bond. Pi bond is broken out. Single bond is present. That is sigma bond is present. CH2 Br. What is this? Ethyl bromide. ethyl bromide. This is called as addition reaction. It is ethene. Very simple one. Ethene, when hydrogen halide is replaced, that means hydrogen halide is addition, you are getting ethyl bromide. So this is called as in this case. But hydrogen halide, particularly, there is a addition of hydrogen halide. There is a specific cases are there. We'll discuss about that is called as a Marconi-Cuff rule. Why? Because here, this particular, it is a unsaturated, that is a unsymmetrical molecule. H plus Br minus. That means H plus is a positive cation. This is a cation is there, anion. It is a negative one. Okay. This is what is unsaturated molecule. Unsaturated compound is reacted with the unsymmetrical molecule, getting of ethyl bromide. Suppose if it is a rich amount, that means number of carbon atoms are increases. What happened? That is explained by the Marconi-Cuff rule. What is Marconi-Cuff rule? It is a essay type question they are asking. What is Marconi-Cuff rule? Explain with the mechanism. So please remember, this is nothing but addition of hydrogen halide property only. Marconi-Cuff rule. So I will explain with that one hydrogen halide, addition of hydrogen halide in terms of the Marconi-Cuff rule. What is Marconi-Cuff rule? We see that one. Marconi-Cuff. Using of the Marconi, what is say definition is Marconi, when unsymmetrical, or you can say that one particularly unsaturated hydrocarbon reacted with the unsymmetrical molecule. See the words. When unsaturated means alkene is reacted with the unsymmetrical molecule. Unsymmetrical molecule is what? That is HBr. Nothing but when unsaturated molecule is reacted with the unsymmetrical molecule, the negative part of the addendum. The words are used by the Marconi, not me. The negative part of the addendum. Sir, which is the negative part of the addendum? Means HBr. When you this is a dissociated into H plus and Br minus. This Br minus is called as a negative part. The negative part of the addendum, which that is the negative part of the addendum, goes to that carbon atom is attached to the double bond, means alkene group, which is having of least numbered hydrogen atoms. Sorry, nothing to worry. I will explain with the example. Okay, what he says, the definition is what he says. We'll see with the example. Let us see the example. I'm writing the example. Please. This is the example which is present in this particular case. This is the CH3, CH, double bond, CH2. See, 1, 2, 3, 4. 4 bonds. 4 bonds. 2. This is. What is the name of this compound, please? The name is? The functional group is ene is there. At what position? First position. It is 1-propene. 1-propene or 1-in-propane. It is also correct. It is a 1-propane. Ene is positioning at the first position. Now, he given as what is taken as this one particularly? We are using of HBr. In this HBr, this is a H plus bromide minus. So, unsaturated compound is reacted with the unsymmetrical molecule. The negative part of the addendum. This is the negative part of the addendum, which having of the carbon. This goes to the negative part of the addendum goes to that carbon is attached with the double bond. This carbon is attached to the double bond. This carbon is attaching of double bond. In this carbon atom attached to double bond having of less number of hydrogen atom. This carbon is having a less number, or this carbon is having of less number. This carbon is having second carbon only is having of only 1 hydrogen. But first carbon is having of 2 hydrogen, which goes to the least number of hydrogen atom is the formation of major product only. So there is a possibility of 2 isomers are possible. So first possible, That means 1 CH3, that is a formation of bromine, that is a negative part of addendum. Here goes to here and CH3. The hydrogen will be goes to. There is a chance of one more chance. There is CH2, CH2 here. This means 2-bromopropane. It is called as the iso. I given as a chain isomers. One carbon is attached to the second carbon. It is called as iso. Okay, isopropyl bromide. Isopropyl bromide. It is called as. Okay, so you are using of this particularly isopropyl bromide and normal N-propyl bromide. This is normally, or you can call as 1-bromopropane. 1-bromopropane. This is called as 2-bromopropane. Okay, so two isomers are possible, but he says that isopropyl bromide is major compound. This is the major. You are getting off. This is a major compound. It is a minor compound. It is a 97% of the compound is present. It is only 3% of the compound is obtained. So again, I am repeating the definition of the Marconi-Kafka fluid. Unsaturated compound is reacted with the unsymmetrical molecule. The negative part of the addendum goes to that carbon is attached to the double bond is having least number of hydrogen atoms to form a major product is called as Marconi-Kafka rule. Understood, I think. Negative part of the addendum means this is the negative part of them. Ekkada potundata carbon double bond దగ్గర ఉన్న కార్బన్ దగ్గర ఉన్న తక్కువ హైడ్రోజన్ ఉన్న కార్బన్ దగ్గర పోతుంది అంటున్నారు. తక్కువ హైడ్రోజన్ ఇక్కడ ఉన్నాయి కదా సెకండ్ కార్బన్ దగ్గర. More carbon atom, that is the double bond carbon atom. There are more hydrogens. Two hydrogens. We are having of 2 hydrogens on the first carbon atom, but the second carbon atom is having of the only 1 hydrogen, which is having compulsory double bond. Double bond దగ్గర ఉన్నది అని చెప్తున్నాడు. ఇంకెక్కడిది కాదు, ఇది కాదు, ఈ కార్బన్ కాదు. Which is having of double bond. That carbons only. Here these 2 carbons is having of double bond. In these 2 carbon atoms, which is the least number of hydrogens are there? Second carbon is having of least number of hydrogens, not the first carbon. First carbon is having of 2 hydrogens. So the negative part of goes to the second carbon only, which is the major product. Isopropyl bromide is the major product is formed. How it is a form, sir? The mechanism is involved like this. Mechanism, if you take the mechanism, the first step, the initiation step, the reagent is HBr. It will be taken as H plus ion and bromide minus ion. Okay, so initially what happened? CH3 CH double bond CH2. Slow step. The slow step meaning H plus ion will be stored. That is a slow step. That is a H plus ion will be attacked first one.
Video was not clarity, sir.
Sorry, ma? In between you are disturbing. Anything else?
Swati, mute lo pettamma.
Video was not clarity, sir.
Remaining you are listening, ma. You keep in the mode your devices. చూడండి ఇక్కడ మనం ఏం చేస్తున్నాము ఫస్ట్. సో ఇట్ గోస్ టు ద ఫస్ట్ స్లో స్టెప్ లో మనకు కార్బోకాటయాన్లు వస్తున్నాయి. మీన్స్ CH3 CH3. This is called as isopropyl carbonium ion. Isopropyl carbonium ion. Okay, simultaneously.
Sir, the board is not clear, sir.
Simultaneously you are getting off CH3 CH2 CH2. This is N-propyl carbonium ion. N-propyl carbonium ion. See the mechanism, how it is. It is a slow reaction. Hydrogen is present at one isopropyl carbonium ion, N-propyl carbonium ion. Now, this particular isopropyl carbonium ion. Next, that means this isopropyl carbonium ion is react readily with the negative part of the addendum, formation of CH3, CHBr, CH3. This is the isopropyl bromide. Isopropyl bromide is the major product which is formed your reaction only. That is isopropyl bromide only.
Sir, video is not clear.
Video is not clear. Actually, the pens are not properly writing, Amma. That is a problem. Not video. I'll write again. So this isopropyl bromide. This is isopropyl bromide. This is isopropyl carbonium ion. Isopropyl carbonium ion. Negative part with the post reaction. This is the first reaction. Formation of immediately CH3, CHBr and CH3. This is called as isopropyl bromide. It is a major product. It is a major product. Sorry, the ink is not getting off properly. What happened? We don't know.
Yamani.
Yamini ready. She is disturbing. She is not disturbing.
Please, you can host everyone, sir.
Tarema. So all of you mute your devices. Anybody is Yamini is there? Please keep the device mute, Amma. Mute your device. So this is a isopropyl bromide. Next one is that is CH3, CH2, CH2 plus. This is N-propyl carbonium ion. N-propyl carbonium ion. The negative part of the addendum with the fast reaction will formation of N-propyl bromide. N-propyl bromide, which is a minor product is obtained. It is a minor one. This is a 97% you are getting. This is a 3%. It is about the Markovnikov rule, the mechanism. Markovnikov rule mechanism is involved like this. So that is nothing but he says that whatever the negative, that means bromide ion will be majorly attacked on the less number of hydrogen which is having a double bond. That is called as a Markovnikov rule. Another rule also given as anti-Markovnikov rule. Anti-Markovnikov rule, what is that? It is nothing but in presence of peroxide. Here in the Markovnikov rule, you are getting of two isomers. One is the isopropyl bromide, another is the N-propyl bromide. But in the isopropyl bromide is the major product, this is a minor product. But in presence of the peroxide, when hydrogen bromide is reacted with the whatever the alkanes, only one compound is formed, that is N-propyl bromide only. That is called as anti-Markovnikov rule. Why anti-Markovnikov? The Markovnikov rule is violated. That's why it is called as anti-Markovnikov rule. Why it is violated? Because of peroxide effect. Because you are using of the peroxide is the catalyst is used. Previously you are not used any catalyst. But in presence of the peroxide, what you get? Only one isomer is present. Only one isomer is possibility present, but no getting of the two isomers. So it is called as anti-Marconi Kafrul. Let us have the anti-Marconi Kafrul. It is also called as this is called as peroxide effect. It is nothing but peroxide effect. Anti-Marconi Kafrul is also called as peroxide effect. Why it is formation means just simply we can take it as previous example only. I'm taking off this one. This is 1 propene. 1 propene is added with the hydrogen bond. That is hydrogen halide in presence of peroxide. In presence of peroxide, you will getting off only one compound, that is 100% compound, CH2Br, that is N-propyl bromide. N-propyl bromide, 100% product is obtained. This is because of peroxide effect. That's why it is called as a anti-Marconi Kafrul. That means Marconi Kafrul is violating the rule, means that's why it is called as anti, because of the peroxide effect. What is the mechanism is involved in this peroxide means? Just if you see the first peroxide is ROOR. This is a formation of simple RO free radical is formed. RO free radical will be getting off this to the free radical. You are getting of the mechanism it will be changes to the bromide free radical only. That means this second step, this particular RO and HBr, formation of ROH alcohol is formed and bromine free radical is present. In the third step, this particularly isopropane, that means 1 propene is reacted with the bromine free radical. You are getting of N-propyl bromide. N-propyl bromide is formed. This is the major product is present. Due to of this peroxide effect, it is called as a peroxide effect. So that you are getting off this compound, it is called as an anti-Marconi Kafrul. Okay. So friends, in the examination, sometimes they ask the both. They are asking in the 10 marks question, what is Marconi Kafrul? What is anti-Marconi Kafrul? It is comes under the chemical properties of the alkenes only. Only the thing is the negative part out of addendum, which goes the major product means the carbon compound having a double bond is present of the least number hydrogen atom. The negative part of addendum will goes to the major product, and the remaining carbon atom that having of the more number of hydrogen atom will having of the minor product. That is the case we are using of that one. This is a second chemical property of that one, comes under the hydrogen halide, addition of hydrogen halide. Now you see that one. Next one is the ozonolysis. Sometimes they ask the property of ozonolysis. We'll go to the ozonolysis. Ozonolysis means what? Addition of ozone. When the alkene is simply, when alkene, this is a double bond, alkene is reacted with the ozone, formation of simple ozonide is formed. This is the ozonide. This ozonide is unstable and also explosive nature. That ozonide is unstable and also explosive nature. Immediately it is hydrolyzed in presence of peroxide. That means we are getting off hydrolysis of ozonide. This ozonide will be hydrolyzed. Formation of CHO. This means we are getting off the aldehyde group. That is HCHO. That means CH2O is present. So you are writing of formaldehyde. This is a formaldehyde. Two molecules of the formaldehyde. CHO like this. This is a CHO. H2O2. So I'm writing off two molecules here only. HCHO. This is a formaldehyde and hydrogen peroxide is removed. This is called as one of the ozonolysis. So in the examination, if it asks what is the ozonolysis means, nothing but when unsaturated hydrocarbons are reacted with the ozone, formation of ethylene ozonide or alkene ozonide. If the ethene is taken, ethylene ozonide. Ethylene ozonides are unstable and explosive in nature. That ethylene ozonide on hydrolysis, you are getting off the carbonyl compounds, particularly here carbonyl compound ethene is getting off the formaldehyde and hydrogen peroxide is liberated. This is also asking for the 5 marks bit. Okay, ethene is ozonolysis, you will getting off ethylene ozonide. That hydrolysis you will getting off formaldehyde, 2 molecules, 2 moles of the formaldehyde and 1 mole of the hydrogen peroxide is getting. Next, fourth one is the polymerization. It is also very important for examination point of the fourth property is chemical property. Polymerization means what? Generally, what do you mean by polymerization? Polymerization means large number of small molecules joined together. Large means more than 100. Large number of small molecules are joined together to form a big molecule without elimination of anything is called as polymerization. So friends, here I use broadly explain the polymerization means one molecule is there, another molecule means one molecule, another molecule joined. It is called as a monomer. It is called as a monomer. This monomer is added one more molecule. It is called as a dimer. If dimer is added one more molecule, it is called as a trimer, tetramer, pentamer. Like that, it is goes on increases. Like you are using of 100 molecules, more than 100 molecules, small units are joined together. Small units, more than 100 small units are joined together, formation of a big molecule, very giant molecule, big molecule. This process is called as a polymerization. In this case, particularly alkenes, ethene or ethylene. So CH2 double bond CH2. I am taking off n times. N time is how many number? 1000 or 100, whatever. This is called as ethylene. Commonly named as ethylene. Under polymerization, under addition of that one polymerization, you are getting off polythene. It is nothing but polythene. What is the polythene? You are carrying covers, carry bags. Carry bag, nothing but this is a preparation. Very simple preparation. That is nothing but the carry bags are prepared from means of ethylene molecule only. Every day you are using the wastage of the carry bags, number of carry bags which was not decomposed by our soil. So that carry bags are nothing but the formation of the polymerization. It is nothing but ethylene is polymerized. You are getting a polythene. Okay. So friends, this is about the polythene. Now this is the alkenes are over. Next topic is in this alkene series, alkadienes is there. Few minutes I will complete the alkadienes also. Alkadienes. What is the root word is alk? Diene means 2 double bonds are present. In between the carbon-carbon, 2 double bonds is there. This is the carbon-carbon 2 double bonds. That is called as alkadienes. So the alkadienes are the first member in this family. Alkadiene is, I will give the writing of the structure is see 2, 4, 2, 3. Sorry, here you see that one. Okay, I will write one more. Otherwise, you will confuse. This is a CH2. Let us now this clarification. 2, 4. Okay, 2, 3, 4. 1, 2, 3, 4. This is a 4. Now the name the compound this one. The functional group is this one. This is the functional group. At the first position, second, third, and fourth. At first and third position is there. 1,3-butadiene. This is the 1,3-butadiene is the first family member of the alkadiene series. 1,3-butadiene is a very, very important one. 1,3-butadiene. Okay, we are using of this one structure because of consisting of 2 double bonds are there. 2 double bonds are there. This is a 1,3-butadiene. Alkadienes it is called as. Now these alkadienes are classified into 3 categories. The classification. I am using of the classification. What is the classification? The first classification is conjugated dienes. Conjugated diene. What do you mean by the conjugated diene means? The double bond is separated by the one single bond. the double bond, this is the double bond. It is separated by the one single bond. This is the one single bond. Now you can write the name. Here 2 required, here 1 required, here 1 required, here 2 required. What is the name of this one? Just now you use it, that is 1,3-butadiene. 1,3-butadiene is belongs to the conjugated diene. What do you mean by the conjugated diene? The diene is separated by the one single bond is called as conjugated diene. Nothing but. The diene is separated by the one single bond is called as conjugated diene. Next, isolated diene. Next is the isolated diene. The classification is also asking for the 5 marks. Isolated diene means the diene is separated by the more than one single bond. The diene is separated by the more than one single bond. Previously, only one single bond is separated, but here more than one single bond. Let us see that one. Now double bond, one single bond, another single bond, other means more than one. It is separated. Okay. This is the diene. Now fill in the bonds. This is 2 required. Here 1 required. Here 2 required. Here 1 required. Here 2 required. So number 1, 2, 3, 4, 5. At the first position, the ene is there. At the fourth position is there. 1, 4. Okay. Pentadiene. This is 1, 4. Pentadiene is comes under isolated diene. Okay, friends. This is 1, 4. Diene is nothing but your isolated diene. Next, third is cumulated diene. Third is cumulated diene. See, friends, conjugated means the diene is separated by one single bond. Isolated means the dienes are separated by more than one bond, more than one single bond. Cumulated means the diene is present on the same carbon atom. The diene is present on the same carbon atom. See, this is a diene. Okay. So this is diene is present on the same carbon atom, which is called as what is the, what do you call? This is a cumulated diene. That cumulated diene is nothing but the, what is the name of that one? So I'm writing off this one. So here 4 is there. So at one position, second position, third. This is a means 1, 2 propadiene, 1, 4, 1, 2 propadiene. This name is alene actually. IUPAC name is 1, 4, 1, 2 propadiene. This comes under cumulated diene. Okay, this is about the classification of the dienes. So very important for your examination point of view. Diene is nothing but 2 double bonds are present in a molecule. If 2 double bonds are separated by one single bond is called as conjugated. If 2 double bonds are separated by the more than one single bond is called as isolated. If 2 double bonds are present on the same carbon, it is called as a cumulated diene. Okay, this is about the dienes. Now you will go to the preparations. Very simple preparation. 2 preparations are there. I will write within the 2 minutes the preparations of the dienes. It is only this particular chapter. This topic is only for the 5 marks bits only. Preparations. The preparation will be nothing but when normal you are getting of butane. This is N-butane. N-butane is present of this particularly dehydration. Dehydration means removing of only hydrogen with the help of the chromic acid. This is the chromic acid which is used in the laboratory. Dehydration. The first is called as a dehydration. Dehydrogenation. Not dehydration. Dehydrogenation. Hydrogenation. Removing of hydrogen. That's all. So here what happened? CH2 double bond, CH single bond, CH double bond, CH2. Friends, here what happened? Simply you are removing of hydrogens with the help of the N-butane. The hydrogen will be replaced. So one hydrogen, here using of one hydrogen, and one hydrogen. 4 hydrogen means 2 hydrogen molecules are removed. This is 1,3-butadiene. Butadiene. So this is about the dehydrogenation. And also dehydration also there. The second property, second preparation, dehydration. Dehydration means removing of water molecule. Dehydrogenation means removing of hydrogen atoms. Here water molecules. So what is same I'm using of the all. See what is the name of this compound, please? At first position and also fourth position. 1, 2, 3, 4. 1, 4. Buta. It is a all diol. 1, 4 diol butane. You can call butane diol. 1, 4 butane diol or butadiol. 1, 4 diol butane. All. This is a OL all. Okay. So this particular dehydration agent, again the sulfuric acid or alumina, we can take anything. Dehydrating agent, you can take the sulfuric acid as well as this one. You will getting of CH2 double bond CH double bond CH2, removing of the water molecule. So this is 1,3-butadiene. So these two are the preparation which are present in this particularly preparation of alkadiene. One is a dehydrogenation, another is a dehydration. These are the two preparations of the alkadienes. And the properties, chemical properties, main important chemical properties are there. Properties. One is 1,4 addition. What is 1,4 addition? We'll see that one. 1,4 addition. CH2 double bond CH double bond CH2. Okay. This will be when taking of the bromination. That means halogenation. It is nothing but the halogenation. 1,4 addition means the halogenation how takes place with the help of the bromine. See the halogenation I will be taking off at first position. Double bond, that means here getting off this particularly, that is a bond is shifted, means here the bond is shifted. CH to the hydrogen will be 2, 3, 4, right? It will be shifted to here CH and double bond. Where is this double bond is shifted to here and CH 2, 3, 4, right? CH2. Here also there is a chance. Here also you are getting off one bromination. That bromine is hydrogen, though replacing the double bond is shifted. So it is nothing but 1,4 dibromo 2-butene. 1,4 dibromo 2-butene. This is called as 1,4 addition. This is called as 1,4 addition. There is a one more chance is there is a possibility of here also bromine. Here also bromine. Next, the chance is you are getting off CH2. Here you are having off CH. Here it is called as 1,2 dibromo. 1,2 dibromo butene. 1 butene. This is a 1 butene. This is 2 butene. This is called as 1,2 addition. It is called as 1,4 addition. Specifically, in the examination, they will ask the what is 1,2, 1,4 addition, what is N2 addition is nothing but halogenation of the 1,3-butadiene. 1,3-butadiene is halogenated. You will getting of two isomers. The two isomers are first 1,4 position 1 and the second isomer is at 1 second. First place and second place. That is a bromine is replaced. You are getting of 1,2 dibromobutane. This is called as a 1,2 addition. It is called as a 1,4 addition. 1,4 addition is nothing but, don't confuse. On one carbon and the fourth carbon addition will be takes place. Which addition is bromine is. 1,2 addition means at first position, second position bromine is added. That is called as a 1,2 addition. Nothing but. So don't confuse. This is a very important chemical property. Next chemical property that is always in your examination they will ask what is Diels-Alder reaction. Diels-Alder reaction. So friends, it is also very important. Why? Because it's a name reaction. What is the product you are taking as? Suppose I am taking off this one, CH2. What is this? Just only straight chain. Instead of straight chain, my convenient purpose, I am written like the curved purpose. It is nothing but 1,3-butadiene. 1,3-butadiene is reacted with the malonic ester. This is malonic hydride. You can call as. Okay, this is one that is called as a malonic anhydride. Malonic anhydride. Malonic anhydride means malonic acid, water is removed. Simply, in the malonic anhydride, you are getting off one adduct. What adduct? C. This is 1,3-butadiene. This is a malonic. This you have to practice is just what happened. This double bond will be tossed here. This double bond will be goes to here. So formation of again this product. We are keeping this one. This product. See friends, here this ring, this will be attacked. This carbon atoms. Just double bond will be shifted here. So 2 double bond. Next same product. This is C double bond. It is C double bond O. This is called as adduct. Adduct is formed. Is called as Diels-Alder reaction. Diels-Alder reaction is nothing but what is that? 1,3-butadiene is reacted with the malonic anhydride. Formation of one adduct is called as Diels-Alder reaction. In the examination, they'll ask the 5 marks question. Please remember this one. This is about the yours organic part. So by this organic chemistry is finished little bit. In this case, discuss about the cycloalkanes. Cycloalkanes preparation, Bayesian theory, and also Saxe-Maurer theory. In the Saxe-Maurer theory, how they are explained with the chair conformation and also board conformation. Always the chair direct question is Saxe-Maurer theory. Otherwise, why that means chair conformation is more stable than the board conformation? Explain the question. Means already I know I explained that chair conformation is having of the whatever the C1 and C4 carbon atoms are above and below the plane, there is no repulsion is there. But in the board form, C1 and C4 is the same plan. Due to flagpole hydrogen, there is repulsion is there. That's why board conformation is less stable than the chair conformation. After that, alkenes. Alkenes means important is these alkenes also called as olefins. These olefins are only undergoing of addition reaction. That means unsaturated hydrocarbons are undergoing addition reaction, not substitution reaction. Saturated hydrocarbons undergoing there is a substitution reaction. In that preparation is there, your preparations are there, and the properties, particularly Markovnikov rule, anti-Markovnikov rule. In the preparation, sets of rule is there that you have to learn. Next one, alkadienes. Alkadienes is the classification and the preparation and properties. That is a 1,4 addition and 1,2 addition. Next property is the Diels-Alder reaction. Okay, friends, this is about the complete your organic part. From this organic part, you will get the minimum 30 marks. 30 marks sure you will get. Why? Because you are getting of the 1, 2 short bits, 5, 10 marks, 1 essay type question, 10 marks, 20 marks, almost all. Sometimes 1 short bit is extra from this. That means 25 plus 5 multiple choice, more than 5 sometimes. Sometimes 10 also from this organic part. So minimum is 30 marks from this organic part. Please aware of this one. Please practice it. Nothing but it's a practice. Just like the mathematics we are practicing, like that organic part also you can practice. If any doubt, you will raise that next class or you can post in our WhatsApp group. Okay, friends. Any doubts?
Okay, sir. Thank you.
Right, ma'am.
Explain the formulation, conjugation.
One by one.
Dynes. ఒకసారి డైన్స్ గురించి ఎక్స్ప్లెయిన్ చేయండి సార్.
Dienes.
Accumulated, conjugate, isolated.
Yeah, diene mean nothing but 2 double bonds are present on the carbon. అని చెప్పాను కదా, 2 double bonds carbon ఉంటే దాన్ని డైఈన్ అన్నాను. డైఈన్, డై అంటే 2, ఈన్. ఆ 2 ఇక్కడ ఏమవుతుంది, ఆ కార్బన్ దగ్గర ఈ డైయిన్స్ ఒక సింగిల్ బాండ్ తో సపరేట్ అయితే కాంజుగేటెడ్ అన్నా. అంటే ఫస్ట్ డబుల్ బాండ్ ఉంటది కార్బన్ దగ్గర, నెక్స్ట్ సింగిల్ బాండ్ ఉంటది, ఆ తర్వాత నెక్స్ట్ కార్బన్ దగ్గర డబుల్ బాండ్ ఉంటది, దాన్ని కాంజుగేటెడ్ అన్న. సో 2 double bonds are separated by 1 single bond is called as conjugated. That is conjugated. Next isolated అంటే 2 double bonds are separated by more than 1 single bond అన్న. ఒకటి కాదు, అంతకంటే ఎక్కువ సింగిల్ బాండ్ సపరేట్ అయ్యాలి, దాన్ని ఐసోలేటెడ్ అన్న. సేమ్ కార్బన్ దగ్గర 2 డైయిన్స్ ఉంటే అది క్యుములేటెడ్ డైయిన్ అన్న. అంతేమా క్లాసిఫికేషన్, వెరీ సింపుల్ క్లాసిఫికేషన్. 2 double bonds separated by 1 single bond is called as conjugated. 2 double bonds are separated by the more than 1 single bond is called as a isolated. 2 double bonds are present on the same carbon is called as a cumulated. That's all. In this preparation is N-butane. మనం ఏం చేస్తున్నాము, క్రోమిక్ యాసిడ్ తో చేస్తున్నాము, దట్ మీన్స్ ఆక్సిడేషన్ చేస్తున్నాము, లేస్తే 1,3-బ్యూటాడైన్ వస్తుంది ప్రిపరేషన్. ఆ తర్వాత 1,4-డయాల్ బ్యూటేన్ చేస్తున్నాం, ఆర్ 1,4-బ్యూటేన్-డయాల్, ఇది కూడా అనొచ్చమ్మా. 1,4 అంటే 1 పొజిషన్ దగ్గర 4th పొజిషన్ దగ్గర హైడ్రాక్సీ గ్రూప్ ఉంది, ఆల్కహాల్ గ్రూప్ ఉంది, దాన్నే 1,4-బ్యూటేన్-డయాల్. 1,4-బ్యూటేన్-డయాల్ ను డీహైడ్రేషన్ చేస్తే మనకు వచ్చేది ఏముంది, 1,3-బ్యూటాడైన్. అది ప్రిపరేషన్ అయిపోయింది. ప్రాపర్టీస్కి వచ్చేటప్పుడు ఏముంది, మనము బ్రోమిన్ హాలోజనేషన్ చేసినప్పుడు 1,3-బ్యూటాడైన్ హాలోజనేషన్ చేస్తే 2 ఐసోమర్స్ పాసిబుల్ అవుతున్నాయి. ఒకటేమో 1,4 అడిషన్ అంటున్నాం, అంటే ఆ 2 హాలోజనేస్ అంటే బ్రోమిన్ 2 ఉంటుంది కదా, Br2 అంటాం కదా. ఒక బ్రోమిన్ ఏమో 1 కార్బన్ దగ్గర, ఇంకో బ్రోమిన్ ఏమో 4th కార్బన్ దగ్గర అటాచ్ అవుతుంది, దీన్ని 1,4 అన్నారు. ఇంకోటి ఐసోమర్ ఏం పాసిబుల్ ఉంది, ఒక బ్రోమిన్ ఏమో 1st కార్బన్ దగ్గర, ఇంకో బ్రోమిన్ ఏమో 2nd కార్బన్ దగ్గర అటాచ్ అవుతుంది, దాన్ని 1,2 అడిషన్ అన్నాడు. వెరీ సింపుల్ అమ్మా. డబుల్ బాండ్ చేంజ్ అవుతుంది, అంటే 2 డబుల్ బాండ్ బదులు ఒకటే డబుల్ బాండ్ వచ్చేస్తుంది. ఒక డబుల్ బాండ్ ఏమవుతుంది, బ్రేక్ చేస్తుంది మన హాలోజన్, అది 1,4 అడిషన్. ఆర్ ఇంకో డబుల్ బాండ్ ఇంకో దాని దగ్గర డబుల్ బాండ్ బ్రేక్ చేసేసి 1,2 అడిషన్ తీసుకుంటుంది. ఒకటి 2 బ్యూటీన్ వస్తుంది, ఒకటేమో 1 బ్యూటీన్ వస్తుంది. అంటే 2 బ్యూటీన్ అంటే డబుల్ బాండ్ అనేది 2nd కార్బన్ దగ్గర వస్తుంది 1,4 అడిషన్ లో. 1,2 అడిషన్ లోనేమో 1st కార్బన్ దగ్గర వస్తుంది, 1 కార్బన్ దగ్గర వస్తుంది, 1 బ్యూటీన్ అవుతుంది. 1,2 డైబ్రోమో 1 బ్యూటీన్ అంటాం, అది 1,2 అడిషన్. ఈ డీల్స్ ఆర్డర్ రియాక్షన్ ఏముంది, 1,3-బ్యూటాడైన్ ఈజ్ రియాక్టెడ్ విత్ మాలిక్ అన్హైడ్రైడ్. యు ఆర్ గెటింగ్ ఆఫ్ అడక్ట్. అడక్ట్ అంటే ఏంది, మన ప్రోడక్ట్ అమ్మా, దట్ ఇస్ అ నేమ్ లేదు దానికి. ఇట్ ఇస్ ఐసోలేట్, దట్ ఇస్ అన్స్టేబుల్ ప్రోడక్ట్.
సార్ ఇక్కడ CS2 దగ్గర 1,4 అడిషన్ దగ్గర CS2 దగ్గర ఒక డబుల్ బాండ్ బ్రేక్ అవుతుంది, ఇంకో డబుల్
రీప్లేస్ అవుతుందమ్మా. మనకు 1,3-బ్యూటాడైన్ లో 2 డబుల్ బాండ్లు ఉన్నాయి కదా నాన్న. 1,3-బ్యూటాడైన్ లో 2 డబుల్ బాండ్లు, ఒక బాండ్ ఎగిరిపోతుంది, ఒక బాండ్ ఎగిరి ఒకే డబుల్ బాండ్ ఉంటుంది అలా.
సార్ 2 బ్రోమిన్స్ ఉన్నాయి కదా సార్, 2 డబుల్ బాండ్స్ బ్రేక్ అవుతాయి కదా, మిగతావన్నీ సింగిల్ బాండ్స్ రావాలి కదా.
కాంజుగేటెడ్ డైన్ అమ్మా, ఇదే 1,3-బ్యూటాడైన్ అమ్మా, దీన్ని కాంజుగేటెడ్ డైన్ అంటున్నా. ఎందుకంటున్నావు, సపరేటెడ్ బై 1 సింగిల్ బాండ్. దీన్ని ఏం చేస్తున్నా బేటా, బ్రోమిన్ తో చేస్తున్నా. చేసినప్పుడు నాకు 2 ఐసోమర్స్ వస్తున్నా. ఇప్పుడు ఏం చేస్తున్నా, ఒక బాండ్ ఇక్కడ బాండ్ ని బ్రేక్ చేస్తున్నా, ఈ బాండ్ ని బ్రేక్ చేస్తున్నా, ఈ బాండ్ బ్రేక్ చేసి ఇక్కడ తీసుకొస్తున్నా. అంటే ఏమవుతుంది, CH2 దగ్గర ఒక బ్రోమిన్ వేస్తున్నా, రైట్. ఆ తర్వాత CH అట్లనే ఉంటుంది, ఇక్కడ డబుల్ బాండ్ వేస్తున్నా, ఇక్కడ 2 డబుల్ బాండ్లను ఎక్కడ తీసుకొస్తున్నా, మధ్యలోకి తీసుకొస్తున్నా. ఆ తర్వాత CH2 తీసుకొస్తున్నా, ఇక్కడ బ్రోమిన్ వేస్తున్నా. దీన్ని ఏమంటారు, 1,4 అడిషన్ అంటున్నా. 1,4 డైబ్రోమో 2 బ్యూటీన్, ఇది 2 బ్యూటీన్ అవుతుంది, 2nd ప్లేస్ వచ్చింది కదా. డబుల్ బాండ్ షిఫ్ట్ అయిపోయింది, ఈ డబుల్ బాండ్ ఇక్కడ మధ్యలో షిఫ్ట్ అయింది, ఇది 1,4 అడిషన్. ఆ తర్వాత 2nd దాంట్లో ఏం చేస్తున్నా, CH2 ఇక్కడ వేసేస్తున్నా బేటా. నెక్స్ట్ CH అనేది ఇక్కడ వేసేస్తున్నా, ఇంకో బ్రోమిన్ కూడా. సింపుల్ గా మళ్ళీ CH ఇక్కడ డబుల్ బాండ్ ఏం షిఫ్ట్ చేయట్లేదు, ఇది ఇట్లానే ఉంచుతున్నా. ఈ డబుల్ బాండ్ షిఫ్ట్ చేయకుండా అట్లనే ఉంచుతున్నా అక్కడ. ఓకే, మనకి ఏమైంది చూడండి, బాండ్స్ వచ్చే 2, 3, 4 ఇక్కడ వచ్చేసింది. ఇక్కడ 1, 2, 3 ఆల్రెడీ వచ్చేసినాయి ఈ బాండ్ తో, ఈ హైడ్రోజన్ 4 బాండ్. దీన్ని 1,2 అడిషన్ అంటున్నా. ఏం లేదు, సింపుల్ గా కొంచెం క్లారిఫికేషన్. ఓకేనా, యు గాట్ ద ఐడియా. సో 1,4 దగ్గర పెట్టేసేయండి, ఆ డబుల్ బాండ్ ఇక్కడ షిఫ్ట్ చేయండి. ఇక్కడ ఈ డబుల్ బాండ్ షిఫ్ట్ చేయకుండా 1,2, కానీ ఇక్కడ ఏమంటున్నాడు అంటే 2 ఐసోమర్స్ లో 1,4 అడిషన్ మేజర్ ప్రోడక్ట్ నాన్న, 1,2 అడిషన్ మేజర్ ప్రోడక్ట్ కాదు. ఎందుకంటే ఇక్కడ డబుల్ బాండ్ షిఫ్ట్ కాలేదు కదా. 1 butene, it is a 2 butene, it is 1 butene nana. It is a minor product, is a major product when the bromination will takes place 1,3-butadiene. Okay, so 1,4 addition ఏ చాలా సార్లు అడుగుతారు, 1,2 అడిషన్ అడగడు చాలా మటుకు, 1,4 అడిషన్ గురించి అడుగుతాడు. 1,4 అడిషన్ అంటే ఇది అడిషన్ ఎక్కడెక్కడ జరుగుతుంది. అడిషన్ అంటే ఏంది బేటా, యాడ్ చేయడం. ఏమి యాడ్ చేస్తున్నా, బ్రోమిన్ ఎక్కడ 1st పొజిషన్ లో 4th పొజిషన్ లో, ఆ బాండ్ షిఫ్ట్ చేయండి ఇక్కడికి, అయిపోతుంది. చూసుకోండి, ఆ బాండ్ దగ్గర 4 బాండ్, ప్రతి కార్బన్ దగ్గర 4 బంధాలు ఉన్నాయి లేదా, 1, 2, 3, 4, 1, 2, 3, 4 ప్రతి దగ్గర ఉంటది. ఇక్కడ కూడా 1, ఇవి 2 అయితే 3 + 4 బంధాలు. ఈ విధంగా మనం క్లారిఫై చేసుకోవాలి. ఓకేనా
సార్, మేజర్ ప్రోడక్ట్ మైనర్ ప్రోడక్ట్ కి డిఫరెన్స్ ఎట్లా?
మేజర్ ప్రోడక్ట్ మైనర్ ప్రోడక్ట్ ఏం లేదమ్మా. మనము రసాయనిక చర్యలో పాల్గొంటప్పుడు మనం చేసుకుంటాం కదా, మీరు 3rd సెమ్ లో వచ్చేటప్పుడు మీరు ప్రోడక్ట్ ఉత్పన్నం తయారు చేస్తారు మేడం. రియాక్షన్ చేసినప్పుడు మనకు లభించే ప్రోడక్ట్ రావాలి కదా. మనం ఎంతైతే 5 ml తీసుకుంటే 10 grams అనేది రావాలి కదా. అప్పుడు వచ్చేటప్పుడు 2 ప్రోడక్ట్లు వస్తున్నాయి. అంటే ఒక లిక్విడ్ వస్తుంది, ఒక సాలిడ్ వస్తుంది అనుకుందాం. లిక్విడ్ అనేది మనకు తక్కువ వస్తుంది. అంటే ఇక్కడ ఏంటంటే వెయిట్, అక్కడ ప్రోడక్ట్ వచ్చే వెయిట్ అనేది 3 grams వస్తుంది. ఇంకోటి ఏమొస్తుంది, 100 grams రావాల్సిన ఒక ప్రోడక్ట్ 2 ప్రోడక్ట్లుగా విడిపోయి ఒకటి 97 grams వస్తుంది, దాన్ని మేజర్ ప్రోడక్ట్ అంటున్నా. ఇంకోటి ఎంత వస్తుంది, 3 grams వస్తుంది, దీన్ని మైనర్ ప్రోడక్ట్. తక్కువ పరిమాణంలో వస్తుంది, ఒక్కోసారి కనబడదు మైనర్ ప్రోడక్ట్స్, కానీ 2 ఉంటాయి ఐసోమర్స్. మేజర్ అంటేనే ఎక్కువ పరిమాణంలో వచ్చేది మన ఉద్దేశంలో, ప్రాక్టికల్స్ లో దీన్ని మేజర్ ప్రోడక్ట్ అంటారు. కానీ మేజర్ ప్రోడక్ట్ ఎప్పుడు స్టేబుల్ గా ఉంటుంది, మైనర్ ప్రోడక్ట్ స్టేబుల్ గా ఉండదు అన్న. కొద్దిసేపు మనం రియాక్షన్ వచ్చినప్పుడే మనకు కనబడుతుంది, అప్పుడు తర్వాత అది మాయమైపోతుంది. అలా కూడా కొన్ని రియాక్షన్స్ ఉంటాయి. సో మైనర్ ప్రోడక్ట్ మనం ఏంటంటే ఇంటర్మీడియట్ ప్రోడక్ట్స్ అవన్నీ కూడా. ఓకేనా, రైట్. సో చాలా టైం అయిపోయింది, హాఫ్ అన్ అవర్ అవుతుంది దగ్గరికి, మనం నెక్స్ట్ క్లాస్కి వెళ్ళాలి కాబట్టి. సో లీవ్ ద క్లాస్. సో నెక్స్ట్ విల్ మీట్ ఇన్ ద